Because Sonny and I had had an amazing relationship for years. We were like brothers.
Wreckage is still smoldering when Jim Ritter arrives at the crash site. Though an experienced investigator with the National Transportation Safety Board, Ritter is struck by what he sees.
My God.
There was a lot of fire damage in the wreckage, and the airplane was basically totally destroyed.
Ritter realizes he's facing one of the biggest challenges of his career.
Anytime there's a high-profile case, you're a little more nervous. There's more stress and pressure on you to come up with the cause for the accident.
The pressure is on to figure out what happened aboard Flight 2311.
This December on National Geographic Network. Your favorite excavation show returns.
This is good news.
Using cutting-edge technology, top archaeologists scour around Egypt to unravel the most enduring mysteries of this ancient civilization.
No one's ever documented this temple. We're the first ones to do it.
It was a natural disaster no one saw coming.
Oh my God.
We take you back to the harrowing moments when a day trip turned deadly.
You see drowned victims, but this was quite different.
These survivalists team up with their trusted companions.
Good boy, bring it here.
To compete in an epic wilderness race.
Come on.
That will put their bond to the test. It's Monkey Mania. Take a swing on the wild side as we bring you up close to these intelligent and playful creatures.
Let's go. Come on.
All new this December on National Geographic Network.
You can run. You can hide. Just don't blink. A month of celebration so action-packed you don't want to miss it. Cheetah-thon. Tonight at 8:30. New to National Geographic Wild.
The impact of human ingenuity is everywhere. From the seemingly mundane,
The most elegant, wonderful invention. We all need one immediately.
to the spectacular.
One small step for man, one giant leap for mankind.
We reveal the stories behind the everyday creations that have transformed the way we live.
It's the future.
Great Inventions, Wednesday nights at 9. New to National Geographic.
From America's Wild West to the Great Barrier Reef. Mystifying ruins lay buried beneath the waves.
These ships were maintaining a whole empire.
Using the latest technology, we strip back the present and reconstruct the past.
Many people compare it to something out of a James Bond movie.
The real story is much more interesting.
Drain the Oceans, Tuesday nights at 9. New to National Geographic.
We've got a box fresh, brand new season of Car SOS. And here are some top tips to get you started. Assess the damage.
Look at the state of it. What is that?
Gather vital parts.
Yes!
Assemble your vehicle. And show it off.
I love it, Buzz!
You loving it?
I love it! It's absolutely perfect!
Watch how Tim and Fuzz do it in the brand new season of Car SOS. Monday nights at 9. New to National Geographic.
In Glynn County, Georgia, investigators search for answers at the crash site of Flight 2311. Several people at a nearby trailer park saw the plane go down.
And it come right over top of the house, and it got real loud. It was coming right over these trees here, and then it got extra loud.
The eyewitnesses saw an extreme left roll angle from the airplane, and so we knew that it was some kind of catastrophic failure, a very abrupt failure that would have been difficult for the flight crew to overcome.
Okay, let's start here and work backwards to first impact. I want a record of everything.
You need to look at the crash site to collect the physical evidence. That's the most important aspect of any aircraft investigation.
The investigators look at the wreckage to try and evaluate the sequence of events leading to the crash. They look for the two wingtips, the tip of the tail, the tip of the nose.
A survey of the crash site soon confirms those key pieces are among the wreckage.
That tells us that there was no in-flight breakup and that the airplane stayed intact until it collided with the ground.
Get a shot of this wing for me, please.
For expert investigators, the size and shape of the impact zone is also a clue.
If an aircraft, particularly through trees, has a long swath cut through the trees, the investigators get an idea that the aircraft hit the ground approximately flat in a shallow descent. In this case, the wreckage was very concentrated, which indicated the aircraft hit the ground at a very steep angle.
We need to get some measurements on these trees.
Investigators hope the broken trees will shed light on witness statements about the way the plane was flying.
Seen it fly overhead, and it looked like it was making a wide right turn, but it was unusual because when it turned out, the nose started heading toward the ground, and I was right up toward the entrance of Touchstone, and I heard the explosion and seen the fire and the smoke.
When the plane crashed, it sheared the tops off of many of the trees in the woods there. And so one of the things that we did was we measured the heights of the trees where the tops were sheared off. And that was able to give us a fairly good idea of the roll angle, which was a large left roll. In the plane, you would have felt light in your seat. You would have turned, obviously, to the left at almost 90 degrees.
Get out of it, Chip! Come on!
You know, it would have been a traumatic experience.
Come on, guys. Get us out of this.
What could make it roll so far over?
When the airplane rolled to the left, it could really only be due to two things. Perhaps the pilot wanted to roll to the left, or there was a malfunction that the pilots couldn't counteract.
What do you got for me?
Ritter examines airport flight records. He's looking for anything that might have triggered the deadly roll.
Clear skies on approach. Almost zero traffic.
There were no other airplanes in the area to avoid. It was a nice clear day, so we didn't really have an explanation for why the airplane rolled so violently to the left.
Ritter won't be getting an explanation from any onboard flight recorders. At the time of the crash, commuter planes aren't required to carry them. Investigators will have to solve the mystery of Flight 2311 without one of their most useful tools.
Not having those made the physical evidence all the more important.
What do you got for me? This is the third one.
The engines have been badly damaged in the crash. The propeller blades have been torn off. Did Flight 2311 suffer some kind of engine failure? It's too soon to say. One thing Ritter does know is that the pressure he's feeling from the media is not about to let up. The deaths of Senator Tower and astronaut Sonny Carter are sure to keep the investigation in the spotlight. Ritter is determined not to let the pressure get to him.
Sometimes we feel pressure to do an investigation quickly, but for the most part, it's more important to get it right. And so I would rather take the time and have a good analysis of the evidence before they come out with a probable cause.
We won't find our answers here. Let's get what we can back to the hangar. Wings, tail, engines, instruments.
The question now, can he find enough evidence to ever solve the mystery of Flight 2311? Investigators begin the painstaking task of sorting through the wreckage of Flight 2311. They're searching for any evidence that might hint at why the Embraer 120 rolled sharply to the left and crashed, killing everyone on board.
All right, guys, let's start with the ailerons.
They wonder if one of the plane's flight control surfaces was malfunctioning.
Control surfaces are the movable flaps typically at the back of the wings, the tail, and the fin, which allow the pilot to roll the aircraft, to pitch the aircraft, and to yaw the aircraft. The three motions an aircraft can do.
They need to examine every component of the flight control system.
What you're looking for is continuity of the controls. Are the hinges all intact? All the actuators are in their proper position? Were the control surfaces themselves in a reasonable position at the time of impact?
Ailerons look good.
When we examined the control surfaces, we didn't find anything unusual at all. Everything checked out normally.
So if the control systems were all working, why would a plane do this? Left bank, almost 90 degrees, then almost straight down. Maybe the engine?
Without the black boxes, it's basically a process of elimination. We analyze all of the physical evidence and come up with the most compelling scenario that matches that evidence.
All right, let's see what we can find in here.
If one of the plane's two turboprop engines failed, it might explain why the plane went into such a steep roll.
We wanted to look for any indications of an engine problem, so we retrieved both the left and the right engine and their propeller systems and took those back to the laboratory for further examination.
Investigators soon find some telltale evidence. Leaves and branches inside the engines.
When we find vegetation in the engines, that tells us that the engine is operating because it's sucking in air and it's pulling in the leaves and the vegetation, and that's an indication that it's making power.
This one was spinning to the very end, no doubt about it.
We confirmed that both engines were operating right up until the moment of impact.
That's it!
With engine failure ruled out, Ritter turns his attention to the other main part of the plane's propulsion system.
Let's take a look at these propellers. Thank you.
Tom Houter is an NTSB investigator.
When we started doing testing the propeller system, we didn't know where it was going to lead us, but it was something we had to eliminate, if nothing else.
Deep inside the propeller unit, investigators uncover an important clue.
Aha! There you are. We have a witness mark. Take a look.
There's a small mark where two parts of the propeller mechanism slammed together on impact. The witness mark might be enough to tell investigators how the propellers were operating.
You can literally match up the scratch marks between both pieces, and you'll know what the angle of the propeller blade was from that measurement.
Mark this one. 22 degrees.
The Embraer 120 has what's called a constant speed propeller. The blades spin at a steady rate in flight. When the pilots need more power, the blades twist, changing their angle to take a bigger bite out of the air and provide more thrust.
Slowing for approach speed.
And in flight, it acts like the automatic transmission in a car. It's as if it's changing gears to match the engine load, the speed, whether the plane is climbing or descending, and it does so constantly and automatically without intervention by the crew.
There are witness marks inside both propellers.
Now, this one looks like 3 degrees.
The marks tell Ritter the exact angle of the blades when the plane slammed into the ground.
We immediately noticed a difference between some of the blade angle measurements for the left engine versus the right engine.
These guys had a big problem with their left propeller. The blades were almost flat.
The left side propeller blades are at a dangerously low angle, one that is never used during flight. At 3 degrees, the blades are so flat, they would act like a wall, blocking the flow of air the plane needs to maintain lift.
At certain speeds and certain regimes of flight, if the propeller goes flat enough, you can have a situation where you can't control the airplane.
Investigators study the mechanism used to control the left propeller.
You look at this.
They make a disturbing discovery.
It's completely worn down.
The teeth on a key piece of the gear mechanism, known as the quill, are almost entirely worn away. Investigators may finally have the lead they've been looking for.
This is what it's supposed to look like.
With its teeth worn away, the quill can't lock onto the gear system that controls the angle of the propeller blades. The discovery might explain why the propeller blades slipped to such a dangerously low angle.
Once we noticed that the quill teeth were severely worn, we started theorizing what would happen in that type of situation. And it was pretty clear that control of the propeller blade angles could be lost. That really was a eureka moment for us, because now we had a serious malfunction that we could examine.
This could definitely be it.
Ritter digs into manufacturing reports, trying to find out how such a vital part could have failed. But what he finds only adds to the mystery. The quill teeth are made of an extremely durable, case-hardened metal.
They were definitely made to last.
It's hard to imagine what could have caused such rugged teeth to wear down so badly.
Something didn't work as planned. Let's find out everything we can about every one of these pieces.
Ritter is certain he's found the critical clue. Worn-down teeth on the quill that could have allowed the propeller blades to slip to a dangerous angle. But he soon learns there's a big problem with his theory. The manufacturer says it's impossible. Engineers at Hamilton Standard included a fail-safe feature when they designed the propeller. It should be impossible for the blades to go flat during flight.
Manufacturers have to demonstrate through a number of means that their systems are fail-safe.
All the tests and research that have been done before this said even if you have a disconnect, that will not result in an accident.
If there's ever a problem with the mechanism controlling the angle, the blades are designed to move on their own to what's called the feathered position.
The feathered propeller blade, the leading edge of the blade, is directly into the wind. So that's the most minimal drag, no thrust, but very little drag.
A feathered propeller can't endanger the safety of the flight.
If this rod disengaged because of any cause, the propeller should go to feather, which would result in the loss of the engine, and the crew would be able to cope with that and land on one engine as they are trained to do.
Runways inside.
This has got to be it. This has to be connected somehow.
But Ritter isn't convinced by the manufacturer's assurances. His gut tells him the worn quill did allow the propeller blades to move to a dangerous angle. But without flight data, his investigation has hit a wall. He has no way to prove the quill brought down Flight 2311.
What's going on? You see anything?
it perfect.
Watch how Tim and Fuzz do it in the brand new season of Car SOS. Monday nights at 9. New to National Geographic.
Every Monday.
Quite different.
These survivalists team up with their trusted tales tell of powerful, solitary pharaohs chosen of the gods by divine birth. Whispers can turn myth into legend, but look for the truth and the writings on the wall. Experts use the latest technology to bring facts to light.
She was the power behind the throne.
And secrets out of the dark.
Oh my God.
Lost Treasures of Egypt. Thursday nights at 9. New to National Geographic.
That's very unusual. Could that have been a part of the accident? We didn't know.
Hauter and Ritter study the design of the propeller mechanism.
Tom, look at this.
We don't see anything obviously wrong with the crew. We don't see anything wrong with the structure of the aircraft. We don't see anything wrong with the engines and the flight control system, but we do have a severely worn transfer tube and quill arrangement. Is it possible that this could have resulted in the loss of control?
They discover that shortly before the accident, Hamilton Standard started using a harder, more abrasive coating on a key part known as the transfer tube. Its grooves mesh, like clockwork, into the teeth of the quill. The change had an unexpected consequence.
It turned it into a giant file.
So the splines on the transfer tube were much harder and rougher than the quill teeth, and it was almost like sandpaper, so the tube was actually wearing down the teeth on the quill.
The discovery explains the worn teeth on the quill. But it still doesn't explain the crash. The design of the propeller should ensure it snaps to a safe position, even with the worn part.
The propeller manufacturer believed that they had a fail-safe condition so that even if they had this problem, the propeller blades would be slowly driven to the feather position.
In spite of what all their data says, the investigators want to see for themselves. They set up a test at the manufacturer's facility.
We had an engine and a propeller combination mounted in a test cell.
In order to determine that something is fail-safe, the engineers use a combination of mathematical analysis, very structured analysis, testing in a laboratory, as you can imagine, and by these methods, Hamilton Standard convinced themselves that this propeller would fail in a safe direction, i.e. towards feather.
That's it. It's bolted to the ground.
The question I raised, well, in flight, the aircraft is in turbulence, it's bouncing around, there's different vibrations. With an aircraft on the ground or an engine mounted solidly to the ground, the airplane doesn't behave the same. There's different vibration modes. Is it possible that could change the outcome of the analysis?
I think we need to see it in the air.
Definitely.
One of the problems of doing testing in a laboratory environment, which is very controlled, is that you can't always anticipate what will happen when you go out into the real world.
These small planes do keep you on your toes.
Imagine, for example, an orchestra that rehearses in an acoustically perfect concert hall and then performs outside with random noises without the sound control. You can see how one might miss important factors about the sound.
We've got to see what happens in the air.
I said, well, the only way to really know is let's do a flight test and find out. Let's do something to absolutely determine this is the case, because we are at a point in the investigation, we need to start eliminating things.
The investigation into the crash of Flight 2311 moves to Embraer headquarters in Brazil.
We really wanted to look at what would happen in flight, in an actual flight, with this same malfunction.
Tom Houter meets with representatives from Embraer and propeller manufacturer Hamilton Standard. The team immediately starts preparing for the test flight.
Thank you for doing this.
When I first proposed doing the flight test, it was not well received by almost everybody. People saw no need. Why are we spending the time, the money? Why are we doing this?
Did you mind if I use that table? Okay.
But I pushed hard. I thought, well, we need to really prove this.
Embraer's chief test pilot, Gilberto Schettini, has agreed to put the investigators' theory to the test.
The risks, of course, is part of the game. So you always have to reduce the risk as much as possible, but you cannot avoid it. So you just accept it.
The mindset of a test pilot is one not perhaps of heroic bravery, but certainly one wants to be unflappable in the face of danger and unusual situations, because you're not very productive if you're terrified by the goings-on in the cockpit.
Schettini will fly an Embraer 120 that has been modified to recreate the failure on Flight 2311.
So we've modified the quill. The teeth have been worn down, just like Flight 2311.
A worn quill will be placed inside the propeller unit.
This was potentially very high risk, because once we disconnected the transfer tube in flight, the pilots would have no way to control the propeller.
We put a pitch lock here. It won't go past 22 degrees.
A mechanical lock has also been added to stop the propeller from going flatter than 22 degrees.
It would be too dangerous in the flight test to have the propeller blade go all the way to flat pitch. You'd lose control of the airplane. That was almost guaranteed.
If the blades moved to 22 degrees, then we know that they would have gone flat. All good?
The propeller blades don't need to go completely flat to prove that Houter's on the right track.
It was a high-risk test. We had to take extra precautions in order not to repeat the accident.
Real-time data will tell the team on the ground whether the propeller blades are going safely towards feather or moving dangerously flat.
Everything says that if you have a disconnect, the normal frictional drag within the system will cause the components to rotate towards the feather position. But will that really happen in flight the same way?
They're about to find out.
We are comfortable that this test could be safely accomplished, but there's a difference between believing it can be safely accomplished and knowing.
As the test plane climbs, Schettini takes it over an unpopulated area, just in case.
There was a potential for a severe controllability problem such that the pilots might have to abandon the aircraft and parachute to the ground.
The propellers have been set to a normal angle for flight, around 30 degrees.
EMB 120, do you copy?
There was a lot on the line in terms of the fact that what if this airplane crashes? What if we lose the airplane? Certainly, I'm the investigator in charge. I'm the one, who's basically running this test. This could be all my responsibility.
Copy. We are ready to disengage the prop.
Basically, they would pull the lever that would disconnect the propeller control system from the propeller and see what happens.
The most dangerous part of the test flight is now underway.
I just thought that, well, it's happening. Let's do what we have to do and get this airplane on the ground.
This was, in my opinion, a very dangerous maneuver because, after all, they didn't know what the outcome was going to be, and they already knew the aircraft wasn't controllable under certain circumstances.
Propeller blade angles causing no problems?
No control issues.
We were thinking about the test to do and nothing else. You have to focus in the job that you have to do ahead. And once you focus, you forget about everything else.
As soon as the propeller quill is disengaged, the blades begin doing what they were designed to do, moving towards the feathered position.
As it starts drifting towards feather, we thought, okay, well, this test is going to be a bust. It's just going to prove what everybody said it would do. You could see it in their faces. They didn't say anything, but you could just, hear the relief.
The propeller blades keep moving towards the fail-safe position. For Tom Houter, Brazil is a long way to come for failure. It seems like the test that he hoped would solve the mystery of Flight 2311 is going to leave the investigation back at square one.
This December on National Geographic Network, your favorite excavation show returns.
This is good news.
Using cutting-edge technology, top archaeologists scour around Egypt to unravel the most enduring mysteries of this ancient civilization.
No one's ever documented this temple. We're the first ones to do it.
It was a natural disaster no one saw coming.
Oh my God.
We take you back to the harrowing moments when a day trip turned deadly.
You see drowned victims, but this was quite different.
These survivalists team up with their trusted companions. Good boy, bring it here. To compete in an epic wilderness race. Come on. That will put their bond to the test. It's Monkey Mania. Take a swing on the wild side as we bring you up close to these intelligent and playful creatures.
Let's go. Come on.
All new this December on National Geographic Network.
The impact of human ingenuity is everywhere. From the seemingly mundane,
The most elegant, wonderful invention. We all need one immediately.
to the spectacular.
One small step for man, one giant leap for mankind.
We reveal the stories behind the everyday creations that have transformed the
Frozen Wild, Thursday nights at 8:30. New to National Geographic Wild.
There's nobody that has not been touched by this pandemic.
It's tough right now because, we're struggling.
We have serious demand issues.
For the first time ever, we have to have each other's backs.
I see color. Here we go.
We're all in this together, and we have to make this work.
Well done, Spurs. This is all we got.
Brand new season. Wicked Tuna. Sunday nights at 9 on National Geographic. From America's Wild West to the Great Barrier Reef. Mystifying ruins lay buried beneath the waves.
These ships were maintaining a whole empire.
Using the latest technology, we strip back the present and reconstruct the past.
Many people compare it to something out of a James Bond movie.
The real story is much more interesting.
Drain the Oceans, Tuesday nights at 9, new to National Geographic.
With the cause of the Atlantic Southeast crash still unknown, and the entire investigation on the line, the Brazilian test flight takes a dramatic turn.
We saw that the RPM was increasing slowly, but it was increasing. So we knew that the propeller was going in the wrong direction.
As the flight continues, the blades begin drifting in the opposite direction towards the dangerous flat position.
Here we go.
The aerodynamics, the vibration, the actual in-flight loads on the propeller are something that you just can't predict in a test. It's something that actually had to be flown.
Schettini remains smooth and precise on the controls.
Reducing speed. Easy does it.
We started feeling a rolling moment to the left and your moment to the left.
The blades go as flat as this test will allow, 22 degrees. For Houter, it's a victory. The risky test flight has paid off. Their theory about the crash is back on solid ground.
The Hamilton Standard and the FAA people just went white. I mean, they were just shocked. You could tell that everything they believed had just been thrown out the window.
That's as flat as they're going to get.
Do you have what you need?
Affirmative. We have everything we need.
Okay. Going back.
Once the test point is finished, it is finished. Don't stay around looking for trouble. Go back home.
Good work. Thanks. Seeing the data right then, it took a load off, said, okay, wow. I mean, we now know what happened. It was obvious.
Looks like you have some work to do.
Hello.
The team has just one more question to answer before they can explain the crash. What happens when blades go completely flat?
In the flight test, they were only able to go to a blade angle of about 22 degrees for safety reasons.
Start it.
But during my flight simulations, I went down to flight angles as low as 3 degrees.
Anytime.
In a flight simulator, Jim Ritter recreates the fatal propeller malfunction aboard Atlantic Southeast Airlines Flight 2311.
As the blade angle got to very low values, the airplane was essentially uncontrollable.
The simulation allows him to experience what the test pilot couldn't.
Flight test proved we could have a blade go to flat pitch. Simulator proved you lose control if it did.
Thanks. That was helpful.
You could say that the simulator testing was kind of like the final piece of the puzzle.
Investigators finally understand the full story behind the deadly crash.
When the flight crew began preparations for landing, The teeth on the quill were worn down, still operational.
Slowing for approach speed.
Preparing for landing put renewed pressure on the already worn teeth in the quill. They could no longer hold. Once the teeth gave way, the propeller blades were free to drift to a different angle. As the turbulence of flight and mechanical vibrations from the engine shook the propeller, the blades moved to a dangerously flat position.
The fail-safe failed. The propeller's design couldn't hold the blades at a safe angle, and the plane became less and less controllable.
What's going on? See anything? There's nothing. What's going on with this thing? I can't hold it. Get out of it! Come on! Come on!
For a while, you can kind of fight this, putting in control movements with the wheels, the rudder, but unfortunately, they were in a situation where it didn't matter if you were the best pilot on the planet. You were not going to be able to control that airplane. It's going to roll over, it's going to dive towards the ground.
Ironically, human error is almost always underneath the causes of an accident, even if it wasn't the pilot or a mechanic. In this particular case, an engineering change was made, which, well-intentioned actually, did not work out.
No! That's it. Oh, God. No!
The worn quill teeth was a time bomb waiting to go off.
There was nothing they could have done to save that plane.
What it really felt was, okay, now that we know it, we've got to tell the rest of the world and get operators to start changing their equipment like right now. The fail-safe system doesn't work.
After the accident, additional safeguards were added to prevent this type of failure, a change that affected not only the Embraer, but several other turboprop aircraft as well. The FAA also ordered more frequent inspections of propeller quills.
The most important thing we have learned from the accident at Brunswick is assumptions. You cannot rely on assumptions. It was assumed that ground tests were as good as flight tests. That one assumption, unfortunately, turned out to be fatal for some people.
This December,